Right, thanks for the great introduction. Let's get this started. So my name is Bjørn Wikkeling. I will be building an app in a minute, but first let me tell you a little bit about myself and why I'm here actually. I've been working for Rabobank as a solution architect for a couple of years. Well, at Rabobank we have quite a few applications actually, 45 applications in one monorepo. So when I say applications, actually I'm talking about the front end. So this is all about the JavaScript code that is actually running in your browser or in your app, in your mobile. When you use so the light is very bright actually, let's stand over here. When you use the mobile app for banking, maybe it's interesting to know that if you use that app, it's actually an Angular app that runs in an Android or an iOS shell. So like I said, there are 45 applications running in it. So the code that you run in your mobile device is actually the same as in your desktop browser. Well, you can imagine all those applications have a lot of pages and also many, many lines of code, like almost 2 million lines of code. And that brings a lot of challenges actually to get that all sorted and working together. And there is actually a very interesting talk at 12 from Stefan and Matthijs. They are somewhere in the audience right now. And they will be talking about how this all gets handled in one repository. Because like I said, everything is bundled together in a one big repository. And in that repository, over 120 teams actually work. So that's teams, not developers. So every team consists of like 5-6 developers. So you can imagine how many people actually work on this thing. It's not all front-end developers, obviously, but a lot of people. Yeah, so for those who were paying attention, I was speaking in the past tense because I've actually left Rabobank and I'm now head of software engineering at We Are Reasonable People. We Are Reasonable People is a digital agency based in Rotterdam, and we are working on, let's say, highly advanced software. To give you one example, currently the developers are working on software for ferries in Copenhagen. So we have water taxis there and water buses, like we have in Rotterdam actually. And those water buses are being built by a company in the Netherlands, but they're electric buses, so on the water but electric. And the software that's being built is to estimate and to predict the optimal route for the shipper to take so that the battery doesn't get drained. Very exciting stuff. So if you're interested in this or in Rabobank, just find me on the internet, like the guy said. I'm on LinkedIn, just type in my name. I'm the only one in the world with this Bjørn Wikkeling combination, so it must be easy to find me. And of course, I have to mention everybody's hiring, right? So Rabobank is hiring, but also We Are Reasonable People. So. Great, let's start build an app. So sometimes it's very nice to build everything from scratch, right? To build everything yourself, roll your own, as they say. But it's also sometimes nice to just pick what other people have already built. And this is one of those days where we're going to use stuff that others already have created. So we're going to use Flutter, MLKit, and Dart. So Flutter is a library that has been built by the people at Google. It uses the Dart programming language, and MLKit is a set of libraries and APIs that leverages machine learning on device. So that's always nice if you're at a conference that you don't need the Wi-Fi because it's usually not working. So everything that I will be doing is on device. I've already downloaded all the models and everything, so hopefully that will be working. But I can imagine that everybody is familiar with Dart, the programming language. I guess everybody's familiar with JavaScript, and probably most will also be familiar with TypeScript. So I created a few slides to have a bit of an idea of how Dart actually works. I'm not going into like a crash course for the Dart programming language, but just to highlight some of the syntax ideas. So in JavaScript we can declare variables like this, right? Usually we use let and const these days, but you can still use var if you like. TypeScript is actually the same, but then we have the the typing over there. But in Dart it's slightly different. It's very similar, but slightly different, because you can do it like this, have a variable like this, but you can also say, okay, this is going to be a string. Type is inferred, as is in JavaScript, but you can also say it like this. You can also use other keywords like final, for instance, which you can compare to const. Right, so a function in JavaScript, everybody knows it, right? Just a simple function. TypeScript, similar. You can actually also use this template string thingy in ES6, of course, but yeah, let's get it the old-fashioned way. And in Dart, you can do something like this. So you start with defining the return value, which is a void in this case, or the return type, I should say. Then you define the function, and inside you have the function body. Very, very similar. Classes, this is a JavaScript class. Well, we don't need to explain JavaScript, I think. TypeScript, fairly similar, but then with the types. You have to always keep an eye on the this, right? I often forget to type this keyword. That's where Dart comes in. You actually don't need that at all. Oh, well, not always. So two things to highlight. There's the constructor right here. It has the same name as the actual class. And if you use, for instance, in a method, the local field here, name, you don't need the this variable. Okay, great. So that's like a crash course of Dart, so you will know what I'll be talking about in a minute. So Flutter. So let me explain a little bit about Flutter. Is anyone aware of what Flutter is? Any hands? Oh, actually quite a few people. Oh, nice. Yeah, I'm quite a fan of Flutter, but I have to admit that I didn't use it for like over 2 years, so like 2.5 years or so. So then last weekend I installed it again, and everything was different because they have now Flutter 3. So I had to relearn it, so to speak. So hopefully when I'm going to write a little bit of code in a minute, it will work out. But the guys and girls who just raised their hands, maybe you can help me out if I make any mistakes. So for those of you who don't know what it is, Flutter is like a development environment, like a framework to build apps. And what you do, you write native code, so you write the Dart programming language using the Flutter framework, and then it compiles down to the native code of your platform choice. So for instance, if you want to create an app for Android, it will compile down to, let's say, Kotlin or Java. You can also create apps for instance, Windows or Mac OS. And I think they have like 6 platforms right now. Even TV OS is there right now. So it's quite interesting. So it has a couple of things already built in, like for instance, the material library, where you have material design. And a lot of other stuff. If you build an app for the iPhone, for instance, you have your Cupertino icons, and you have all the styling and everything in the iPhone style or the iOS style. Great. So like I said, this weekend I installed everything already. Then what you do, you create an app. You say, okay, let's create Frontmania app. I already did this because it will be tedious to do it here on stage. And then you have this, right? So you have like a set of files. So let's see what that will look like in reality. Let me just quickly get a little bit of water. Okay, so what we're looking at right now is, oh, that doesn't look too good. Beach ball, there we go. I have a phone here, as you can see, and that phone, the screen of the phone is streamed to the screen over there. And here, let's see, I can make this a little bit bigger maybe. I have an app. That's actually not running. Okay. So let me explain what you see here. So every program, Dart program, has a main function, and that gets triggered automatically. And since we're in the Flutter framework, we actually have a couple of built-in lifecycle methods, like you also have, for instance, in Angular or React. One of the lifecycle methods we have here is build, which will be triggered, and it will build the app. So Flutter is based off of widgets. So everything in Flutter is a widget. Over here to the right, you see like this menu bar and a text in it, and you see that it's called an app bar, and we have here text in it. So if I add, for instance, an exclamation mark, you will see that we have hot reload, and it will actually add it right there. I can also add, for instance, a body, and inside the body I can add another text widget, and I say, for instance, hello crowd. It's probably a bit small, but yeah, as you can see, there is some text right there. There's a hot reload, just like as with web development, but now you're actually developing on device. So this is actually deployed on the device. Oh, yeah, there you go. the demo gods are not with me, I guess. Maybe I should just put this down for a minute. Excellent. Great. So like I said, I'm going to leverage the ML kit library. But before I do, I want to add a couple of things to this app. And maybe before I continue, if you install or if you create a new app, you actually already get an entire app that has a button in it and some sort of counter. I removed all that code and then kept only this. So now you basically have a shell of an app. It's a material app, so it has the material design layout, but obviously you can change that in any way you like. As you can see over here, this is a stateless widget. That means that the widget doesn't have any state, so it doesn't have any notion of changing variables or whatever. And I'm going to change that into a stateful widget. So let's do that. So first of all, I'm going to make this into a state class, which then extends the state with the type of my app. We don't need this anymore. And then the my app class is actually going to extend stateful widget. So in Dart we have this annotation, it's called override, and it means that you are going to override something that is inherited from a previous class. So we're inheriting from the stateful widget, so I am going to I'm going to override this one. Namely, like it says over here, I should implement the create state method, so I'm going to do that. So create state. I'm going to use the arrow method, the arrow notation like we have in JavaScript. And this is actually also returning a state of the type my app. So if all went well, I should still have my device here. Connection not found. I need to restart it, of course, because the cable was disconnected. So let's just see if it works, just to be sure. It takes a little bit of time because it needs to reinstall the APK file, so it needs to redeploy everything to my device. So that takes a few seconds, and there we go. Yeah, there it is. Great, so I actually didn't change a lot, only that we now have a stateful widget, which means that I can now start adding variables. For instance, I'm going to add a variable right here that's going to be of a list type. And the things I'm going to put in that list are the camera description items. And I'm going to call that variable cameras. So let's initiate it with an empty list. And then I'm going to say, okay, so in my main function, I'm going to first make sure that the widget has actually initialized. And then I'm going to say, okay, so those cameras, I want to have all the available cameras of the device, right? So the idea that I'm using is Android Studio. You can also use Visual Studio Code if you like. There's a plugin that also has all the tool tips like you have over here. So it's a future, so we need to add an await statement here. So a future is actually similar to what a promise is in JavaScript. And as in JavaScript, if you want to use await, you also need to add async to the method. So let's add that. And since I'm lazy, I'm just clicking things. So it's going to be returning a future with an empty type, right? So what I've done right now is I've added this cameras list, which is like an array, and I populated that list with all the available cameras. So now what I can say here in my body, instead of this text widget, I'm going to add the camera view widget. That's this one. And I need a camera, but I don't have the camera yet. So I have a list of cameras. So what I'm going to say is, yeah, just give me the first one that's in the list. Let's see if that works. Besides hot reload, there's also hot restart. So I'm going to hot restart it now. Hot cameras, it's actually. Hot restart, and hopefully the camera will then be available. Yeah, so now I can show you what I see, although there's no light anymore in the room. So, let's see. Yeah, maybe we can have a little bit of house light. Yeah, thank you. Yeah, it's you guys. Yeah, there's someone waving even. Yeah. So this is working. So yeah, thanks. So I cheated a little bit because this camera view thingy is actually something that I already wrote here. I won't bother you with all the info. Oh, yeah, actually I brought this stand so that I can put it right here. This should work, right? Let's see. Right. Excellent. So yeah, so bear with me, please. So this camera view thingy that I use over here, I actually cheated a little bit because I already wrote that. That's in this file. I'm not going to go over all the code. It's not too much actually. It's like just over 100 lines. And it initiates the camera and makes sure that we can actually use it. Great. So I was talking about lifecycle methods, right? So we have the build method, but there are also other methods that we can use. So let me add two more. So we've got the init state method. So this initializes the state. So actually it gets called when the state gets initialized. And we can use this to initialize our code that we need. And another one that we can also use is dispose. And that is kind of like when this widget gets disposed, we can do all kinds of cleanup stuff over here. Great. So in the interest of time, I thought, let's just already write some code beforehand, and I'll explain you what I wrote. So I implemented these two methods and added two more, and I will just quickly get those from my Git repo. Right, and then hot reload those. So let me then fold everything, and I will do this in a minute because it's already working. Yeah, actually I didn't want to show this yet, but yeah, let's because this is actually what we want to achieve, right? Let's see. Let me briefly go over this. So we still have the cameras. We now have two more functions added. So I have a detector initialized and process image. So what I'm doing, let me just show it now. I have a video here. Let's see if this works. Yeah, you see? So now I'm using the ML kit to see what's on the video. So it thinks it's a toy. I don't know, probably drinks are toys in computer land. I didn't know about that. So what happens now, the live feed from, it's a toy vehicle, okay, shame. I thought my car would be more like a real car, but anyway. So what happens now is that the live feed from the video is being fed into MLKit, and that analyzes this video images. It was a bit too fast. It analyzes the video and then looks for any objects that it recognizes. So the boat is only, 50% sure only. And this person, it's a person, is dress even, that's correct. So it kind of works. The interesting thing I'll show you right now is that you can actually leverage these models by adding in your own. So here I'm going to initialize the detector, and as you can see right here, this is a model that I'm using. It's actually on my disk, I won't show it, but it's a file of a few megabytes that is a trained model that you can use. And now the really interesting thing comes because you can also train your own models. So for instance, if you want to create an app that recognizes flowers, you can train a flower model and then put it in there, and then you already have the app right now, right? Because I already have like a functioning app. You just need to add a few more bits and pieces to make it like, really useful for the outside world. So not only flowers, but you can also think of other things like birds or what have you. And many of these models have already been created, and you can find them on the TensorFlow hub that's out on the internet. So all freely downloadable. So to wrap things up, let me quickly go back to the code for one more second. Like I said, we have the initializer, so we actually create an object detector, and then we have over here the image that we're going to process, where we use the object detector. And that all gets tied together over here inside the main function, where we now inside the stateful widget, where we now have the stuff actually being given to the camera. You see, so I give it the camera, I give it the custom painter, which is those rectangles, and then I give it the unimage function that's right here to recognize all the objects in the image. So yeah, so this is a very brief demonstration. I hope that I kind of inspired you to start using Flutter and to see if you can use it in your projects or maybe in your home projects, your hobby projects. And you can see that you can leverage code that is already out there, that's already existing, and build something really, really quickly without actually having to write too much code. Because today I only wrote like a couple of lines. In the weekend I wrote like 150 lines or so of code to prepare this. So that concludes my talk. Hopefully it's been a little bit inspiring, and thanks for attending.